Hi everyone and welcome to Tadpoles Lesson 14. Today we're going to be covering geometry. So some basic types of geometry we're going to be learning is, there's, let me count different types. So there's a rhombus, which is basically a type of square. It looks like a diamond. All sides are going to be equal. Next, there's a trapezoid, which has two parallel lines above it. And that's basically all you need to know about the trapezoid. It just has two parallel lines. It can look like that too. It's most commonly used. And there's another trapezoid. It has two parallel lines. That's the main indicator. A square, it has all equal sides with all right angles. Right angles are these things right there. They make that perfect side. A parallelogram is going to have, it's basically a type of rhombus, except one side is going to be different. So there's going to be two sides that are going to be similar, and then there's going to be two sides that are going to be similar but different to the other ones. So these hash marks, basically, they mean they're the same. So the ones that have two hash marks, these sides are going to be the same, and the ones that have one hash mark, those sides are going to be the same. A quadrilateral, none of the sides are going to be the same. A kite, it has two of this sides that are the same, but the other two are not. A rectangle, it has those right angles, but it has two sides that are different and two sides that are different as well. And then the square, again, is all sides are equal, the perfect right angles. A rectangle, again, these ones are different. A quadrilateral, none of them are equal. And what is going on? And a rhombus, which is, again, basically a square diamond, but it doesn't have those right angles. So we're going to identify the type. So for this one, we saw this one. This one is going to be called a kite because it has two sides that are even and two that are completely different from one another. This one is going to be a rectangle because it has those right angles, but not all sides are the same length. This one is going to be another kite because two are the same and the other two are not. This one is going to be a parallelogram because two sides, parallelogram, because two sides are the same and two sides are also the same but different. This one is another parallelogram. This is more of just a memorization thing, you just kind of have to memorize the sides. This one is going to be a trapezoid because there's these two parallel lines right there. This one is going to be the quadrilateral because none of the sides are the same. That was a weird T. This one is going to be the rhombus because it looks like a diamond and all the sides are the same. So it's basically a square but without the right angles. This one is a rectangle because not all the sides are the same, but it does have right angles. This one is another rhombus. Here is a quadrilateral. And then here is a square. I think we got all of them right. Okay, so there's also different types of polygons. So these are ones that have many different sides. So there's a lot of prefixes that we need to know. I think we're just starting at hexa right now. So hexa is going to be 6 sides. Hepta is going to be 7 sides. Octo, I'm pretty sure it's octo. Or octa. Octa is going to be 8 sides. Nona is going to be 9 sides. And deca is going to be 10 sides. So that's kind of a memorization thing. You're just going to have to memorize that. It's not that hard to memorize. We've seen hexagons with stop signs, octagons, all that stuff should be pretty familiar. So let's count the sides. This is 1, 2, 3, 4, 5, 6. So that's going to be a hexagon. 1, 2, 3, 4, 5, 6, 7. That's a heptagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is a decagon. I think you guys have got the hint, so I'm going to give you guys these 3 rows to work on. Let me move the prefixes over so you can see them. Okay, so you guys should be done. There's 1, 2, 3, 4, 5, 6 hexagon. 1, 2, 3, 4, 5, 6, 7, 8, 9 nonagon. 1, 2, 3, 4, 5, 6, 7 heptagon. Here is 1, 2, 3, 4, 5, 6 hexagon. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's a nonagon. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. 1, 2, 3, 4, 5, 6, 7, 8. Another octagon. 1, 2, 3, 4, 5, 6, 7. A heptagon. And then 1, 2, 3, 4, 5, 6, 7, 8. An octagon. There we go. I think we got everything right. Okay, so now we're just going to combine what we've learned so far. Identify the actually, let's do one more exercise of the polygons. So I'm going to give you guys some time to work on these 4 rows and then come back for the answers. Okay, so here is what you should have gotten. If you didn't, maybe try counting again, relearn the prefixes, go back into the video. Okay, so now we're going to identify the type for each regular polygon. So these ones look familiar. 1, 2, 3, 4, 5, 6 sides. That's a hexagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A decagon. 1, 2, 3, 4, 5, 6, 7. A heptagon. Now we're getting into more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonagon. And then here is our square, because those 4 right angles and 4 equal sides. Rectangle, 4 right angles, but not 4 equal sides. A trapezoid, because of our parallel lines. A parallelogram. This one is our kite. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. 1, 2, 3, 4, 5. This is a pentagon. You might want to add penta to our prefix list. Penta means 5. And a rhombus. Looks right to me. Let's keep going. I'm going to give you guys these to work on and then come back for the answers. Okay, so you guys should be done. This one is a rhombus because of its 4 equal sides, but no right angles. 1, 2, 3, 4, 5, 6, 7. That's going to be a heptagon because of its 7 sides. 1, 2, 3, 4, 5. Pentagon because of its 5 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 because of its 10 sides. Here is our quadrilateral because it has 4 sides, but none of them are equal. We have a rectangle. As much as this looks like a square, you have to pay attention to these indicators. These are not the same, which means it cannot be a square. We have 1, 2, 3, 4, 5, 6 hexagon. Here's a kite. Kites are pretty easy to recognize. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonagon. We have a square, a trapezoid because of those parallel lines, and then a 1, 2, 3, 4, 5, 6, 7, 8, a octagon. There we go. Looks pretty good. Now we're going to do translation, rotation, and reflection. So translation means moving from side to side, up to down. You're translating the piece a specific way, but not actually changing the shape of the piece. Next, reflection. You have a sort of axis. It can be Y or X, but I think in this one they're doing Y. So you're basically, it's like a mirror. You're basically going to flip it the opposite way. So like say you have a piece of paper, you're going to flip it, and that's the image that it should create. And then rotation, you're just going to take the entire image and rotate it counterclockwise or clockwise. So identify each shape as translation, rotation, and reflection. So for this one, the first one has not changed its shape in general with where the dot is. So that's going to be translation because I'm assuming it's just moved to the right or up or down. The second one, the dot has actually moved, so you're rotating it. I'm assuming clockwise. You're going to rotate it like this way. So where the dot is over here. So that's going to be rotation. And then this one, if you put it along an axis and you flip the paper, the dot would end up being here as it does over here. So that's going to be reflection. Okay, number 2. This one is the same thing. It's just being moving. The dot hasn't moved. So that's translation. The second one, if you put an axis right here and you flipped it, the dot would, the entire image would move like that. That's a really bad drawing, but that's what this looks like. So that's going to be reflection. And if you twisted this thing this way or whatever way, it would be rotation and look something like that. Okay, for this one, the entire structure has moved, but it hasn't been reflected because it doesn't look the same if there were an axis right here. So that's going to be rotation. For this one, if there's an axis, it would look that if I like flipped it on paper. So that's going to be reflection. And then finally, this one must be translation. Whoops. Okay. This one must be reflection because if there were an axis right here, it would look the same. This one must be rotation if you moved this around because it doesn't look the same as it would, and translation right here. There we go. I'm going to give you guys these 2 rows to work out and then come back for the answers. Okay, so you guys should be done. This one is reflection, translation, and then rotation. Here is reflection. Whoops. This one could be rotation. These ones are kind of the same because if you rotate it in a specific way, you could still get the same image as if you reflect it. And this one must be translation because nothing has changed. This one is rotation because if you moved it around, you could get it over there. This one is translation because it hasn't moved. And this one is reflection. Oh, my handwriting's getting worse. This one is going to be reflection because it would look the same if it was translated across an axis. This one is going to be rotation. And this one is going to be translation because it looks the same. There we go. That looks right. And then our last problem set, I'm going to pause and let you work on this and then come back for the answers. Okay, I'm going to abbreviate it because my handwriting's getting bad. Here is translation. Here is rotation. And here is reflection. Here is reflection. This is translation. And finally, this is going to be rotation. This one is reflection, rotation, and then finally translation, reflection, translation, and then rotation. Translation because it hasn't moved, rotation, and then reflection because it looks the same if it was flipped. Here's translation, reflection, rotation. Translation, rotation, reflection. And finally, translation, rotation, and reflection. Pretty easy lesson today, just a lot of definition and identification, but it just comes with practice. If you have any questions, just let me know, and have